Hello everyone. Today we're going to talk about electromagnetic radiation. Electromagnetic radiation in classical physics, the flow of energy at the universal speed of light through free space or through a material medium in the form of electric and magnetic field that make up electromagnetic waves such as radio waves, visible light and gamma rays. In such a wave, time-varying electric and magnetic fields are mutually linked with each other at right angles and perpendicular to the direction of motion. An electromagnetic wave is characterized by its intensity and frequency of time variation of electric and magnetic fields. What is quantization? In signal processing, analog signals are often turned into digital ones, and quantization describes a part of that process. Going from one form of information to another can help us get a grasp on the basic idea of quantization as it applies to the field of physics, which is a bit different. Quantization in physics is the movement of thinking of physical phenomena from being in terms of classical mechanics to terms of quantum mechanics. Quantization also encompasses the mathematics that underlines this change in thinking. Quantization and light. One of the first topics studied during an introduction to quantum mechanics is the quantization of light, which allows for light to be considered as more than just a wave. Recall that light in physics refers to the entirety of electromagnetic spectrum, not just visible light. The quantization of light refers to light behaving as quanta or photon, which is like a packet of energy. A quanta carries an energy that is dependent on frequency and Planck's constant. E equals to hf. Planck's constant has a value 6.626 into 10 raised to the power minus 34 joule seconds. These packets of light energy can be partially absorbed or emitted. Light quanta can only exist and interact as discrete packets of energy. This is different from more analog way that light is treated in classical mechanics. Note that discrete and quantization are not synonymous. There are many topics in quantum mechanics that deal with waves and probability. Photoelectric effect. Heinrich Hertz discovered photoelectric emission in 1887. Photoelectric effect, the phenomena in which electrically charged particles are released from or within a material when it absorbs electromagnetic radiation. The effect is often defined as the ejection of electrons from a metal plate when light falls on it. In a broader definition, the radiant energy may be infrared, visible or ultraviolet light, X-rays or gamma rays. The material may be solid, liquid or gas, and the released particles may be ions, electrically charged atoms or molecules, as well as electrons. The phenomena was fundamentally significant in the development of modern physics because of the puzzling questions it raised about the nature of light, particle versus wave-like behavior that were finally resolved by Albert Einstein in 1905. Experimental setup for photoelectric effect. This setup consists of evacuated tube, photosensitive plate, metal plate, monochromatic light, battery, voltmeter, ammeter, Evacuated tube consists of photosensitive plate, that is emitter, and a metal plate, that is collector, so that the electrons could freely flow from emitter to collector without any air resistance. Photosensitive plate, the emitter, is to absorb the visible light and emit electrons. Metal plate, collector, to receive electrons emitted from the emitter, thus constituting a photoelectric current flow from collector plate to the emitter plate, that is opposite to the flow of electrons. Monochromatic light of short wavelength, meaning high frequency. Battery, to accelerate emitted electrons through a potential difference. Voltmeter, to measure the potential difference between the emitter and the collector plate due to photoelectric current flow. Ammeter, to measure the value of photoelectric current. Variation of photoelectric current with intensity of radiation absorbed. When the values of photoelectric current were plotted against the different values for intensity of light, it was observed to be a straight line passing through the origin. It proved that photoelectric current, which is number of photoelectrons flowing per unit time, is directly proportional to the intensity of incident light. Case 2. When collector plate was kept at lower potential, retarding potential with respect to the emitter. As the negative potential of collector rises, the photoelectric current falls. This is because the electrons emitted will experience a strong repulsive force from the collector. As the retarding potential is further increased, even the electrons having maximum kinetic energy will be repelled by the repulsive force of the collector, and hence the photoelectric current becomes zero. This corresponding minimum value of retarding negative potential, for which the photoelectric current becomes zero, is called stopping potential or cutoff potential. It is denoted by V0. When the variation of photoelectric current was plotted against the potential for three different values of intensity of incident light, keeping the frequency constant, it was observed that the stopping potential was constant for all values of intensity. Thus, stopping potential is independent on the intensity of incident light. On the other hand, saturation current got higher for higher values of intensity of absorbed light. Variation of photoelectric current with frequency of incident radiation. The variation of photoelectric current was plotted against the potential for three different values of frequency of incident light. It was observed that the saturation current was constant for all the values of frequency. Thus, the saturation current is independent on the frequency of incident light. However, stopping potential got higher in the negative direction for higher values of frequency of absorbed light. It was also found that after reaching a certain minimum frequency value, stopping potential followed a linear relationship with the frequency of incident radiation. This minimum value of frequency of incident light required for photoelectric emission to take place was called threshold frequency. The value of threshold frequency is fixed for a specific material, and it changes from one material to another. Thank you.